Hello everyone. In this video tutorial, I'm going to introduce you a new plugin for the generating CDP concrete damaged plasticity material, which is widely used in concrete simulation in Abaqus software. Previously, we used the Excel sheet to develop CDP, and it was very time consuming. So in this plugin, you can actually access freely from my YouTube channel, and this plugin is totally free. And you can even update, even you can implement your own developed code in the plugin system. So when you receive this plugin, you can just copy and paste it in the plugin of folder of your Abaqus. It can work until Abaqus 24 and also latest version. So then you come to the Abaqus plugin, and here is called CDP Concrete Creator version 1. So the first input is model, which is the model name. In case if you change, you write exactly that model here. And the second is you give a proper name for the concrete. So let me see, instead of C30, I'm gonna use a concrete with 30 megapascal compressive string. So this is the input. Additionally, this CDP is only a work for normal concrete, which has at least 100 megapascal compressive strength. So for all ultra or high performance concrete, we have another plugin which I will introduce later. So there is two law. One is for the compression law, and second is for the tension law. So you can choose which one you want. If in case if you need to know what this law means, you can go and read about this in some literature. Additionally, for the tension law, you must choose one of them. So additionally, we also have custom. So I will use LCACI split 2, and it automatically will calculate based on this 30 megapascal the tension of the concrete. And here is the key input. So you must give introduce 30. So the FEC is 30 megapascal, and the density is a ton per cubic millimeter. So remember, in Abaqus, we only use consistent units. That is actually based on the user definition. So I will use a megapascal, and then that length will be millimeter, and the time will be second. So you cannot change now here, but you can change. You cannot change the this unit. So I use megapascal, millimeters, or force as Newton, time is second. And then you can change, in case if it is lightweight concrete, you can change the density as well. And here is the portion ratio. In case if you have tested a different portion ratio, you can add it. So the dilation angle is also variable. It can be like from 30 degrees to 50 to 55 degrees. So you can change it. So in this case, I'm going to use it 40. Eccentricity is kept. This eccentricity is actually a default, and you cannot change it. But if you change, maybe the response is a little bit different. But I didn't work with this one. And this also can be a variable, and for the ultimate or high strength concrete. But for normal concrete, this is okay, and there's also default. But the viscosity is a variable. In case if I wanna use a high viscosity concrete, so I can give 0.5, or you can give a small number. The tension recovery is also can be changed, like between 0 to 1, so you can consider this. And the compression recovery is also between 0 and 1. So I keep it 1. So I'm create, and the material is automatically created in my property section. So this is it. FEC 30 megapascal CDP material. So if I go here, and you can see the density is created, the modulus velocity automatically based on the ACI standard is calculated. The concrete damage positive 40, 0.1, and 0.1 viscous per meter. The compressive strength. And now I want to plot this one, create x1, and with corresponding also to the this is the tension recovery, which is giving 0.5. You can give 1. So I'm going to go 1, create, and then the tensile, and the tensile. This is the tensile should be less, because the concrete and the tensile is quite sensitive. So if you get more points, so it's very difficult to convert during the analysis, especially for the dynamic analysis. So you can increase this by updating the code. And the tensile damage. Create. We have 4 graphs from the this compression, tension, and corresponding damage edge. If I go to the visualization and I want to plot the curve which is created, plot, and it's the compressive curve of the concrete, and this is the second plot for the corresponding compression damage, and the third is for the for the tension, and this is the tension area, and the last one is for the corresponding tension damage. So we have this data as well. You also can export this data in case if you want to put in your paper. Okay, this is all, and we also have conducted some verification, and the code is quite accurate with the experiment. And additionally, if I go back and this time I want to create, let's go to here and create this time, giving FVC 50, and I must change this one to 50, and the rest should be as it is. So, but this time we use tension formula EC2, and it's automatically came. And you can go see the intro and compression, all of this. So this is a new plugin which can help you to create CDP material easily. Thank you for watching. If you have any question, please put in the comment and we'll find time to answer you. See you next time.